We are talking about solving quadratic equations by completing the square, and we have a couple examples here. Again, we have to make sure that our a value is 1, in this case it is, and then we want to get our c value to be equal to 0. So in order to do that, I'm going to subtract 8 from both sides of the equal sign, and that will leave me with x squared minus 10x. We're going to have to substitute in some c value later, and that's going to be equal to negative 8, and then plus whatever we add to the left side, we have to add to the right side in order to keep our equation balanced. So our c value that we're trying to calculate, again, our c value is going to be equal to our b value divided by 2 and then squared. In this case, our b value is negative 10. So what we get, negative 10 divided by 2 is negative 5. And then we'll square that negative 5, and that is equal to 25. So we're going to add 25 to both sides of the equal sign. And that will get us our trinomial that we'll be able to figure out what a perfect square is. So when we get to that point, trying to calculate our binomial, our only two values that multiply together to get to x squared are x and x. And whatever this value is here that we're squaring, that goes in our equation here. So it has to be negative 5 and negative 5. And then on the right-hand side, we just have to add these two together, and then we get 17. So now we're left with x minus 5 squared equals 17. We want to get the binomial by itself, so we take the square root of both sides. And the reason we did that is our radical cancels our squared. And we're left with x minus 5 is equal to plus or minus the square root of 17. We can't reduce that, so we just leave it that way. We don't want to have a decimal, we want to have an exact answer. And then we can add 5 to both sides to get x by itself. And then we're just left with x equals 5 plus or minus the square root of 17. And that is our final answer in simplified form. Now we can look at number 7. So the difference between number 6 and number 7 here is our coefficient for number 7 is a 2, but we need it to be a coefficient of 1. So we're going to have to work with that to figure out what needs to happen to get that taken care of. So the next thing is we want to get rid of that c value. So we're going to add 14 to both sides of the equation. And that's going to leave us with 2n squared minus 4n. We're still going to have to figure out what the c value is. And that's going to be equal to 14. And we'll still have to add whatever that c value is to the right side as well. Now, we need our a value to be 1. So how do we make this a value to be 1? Well, we divide this left side, or we factor out a 2. So we can bring the 2 out front. 2n squared divided by 2 is just n squared. Negative 4n divided by 2 is negative 2n. And we still have that value, which is going to be our c value. But on the left side, whatever that c value is there, that is going to have to be multiplied by that 2. And that is going to be equal to 14. And then it's going to be plus whatever that c value is, but it's also going to have to be multiplied by 2 because if we have to keep the equation balanced. So again, our c value that we have to calculate, we're going to take up our b value and divide it by 2 and then square it. In this case, our b value is negative 2. So negative 2 divided by 2, that's equal to negative 1. And negative 1 squared is equal to 1. So here's a little bit of a trick that we haven't dealt with yet. If we add 1 here, that's 1, but it's inside this parentheses, which has a 2 out front. So if we distributed the 2 into the parentheses, we get 2n squared minus 4n, and it would be plus 2. So really, we're adding plus 2 to both sides of the equation. But now we have it in a form where we have our trinomial that we can find the perfect square for that trinomial. So we still have the 2 that has to stay there. Then we have our binomial. Only numbers that multiply together to get n squared are going to be n and n. And then whatever value that we have squared here, that just stays in the equation. And over here, that is going to be equal to 14 plus 2 is 16. Now we can rewrite the equation with our perfect square binomial. So we have 2 times n minus 1 quantity squared is equal to 16. Previously, we got to this step here, and we could just take the square root of both sides, but we have another step we have to do beforehand. We have to divide both sides by 2. So if we divide by 2 and divide by 2, then we get n minus 1 squared is equal to 8. Now we can take the square root of both sides. So the square root on the left, our square root cancels our square. And we'll move it up here, running out of space a little bit. So we get n minus 1 is equal to plus or minus the square root of 8. Well, we can reduce this radical, and the way that we can reduce that radical is we can say the square root of 4 times the square root of 2. We know what the square root of 4 is. The square root of 4 is 2. So we can rewrite that as n minus 1 is equal to plus or minus the square root of 4 is 2 and the square root of 2. So that's just another way to rewrite that to simplify our radical. And then we can add 1 to both sides of the equation. And then we're left with n equals 1 plus or minus 2 square root of 2. And then that is our answer in simplest form.